All right, for anyone joining us from LinkedIn and YouTube, welcome to the webinar once again. We are going to start the webinar in another minute. In the meantime, you can introduce yourselves, tell us your name, the city you're from, and what you're currently doing as well. So I'm just going to take a quick look at the chat. Hi, Shweta, joining from Bangalore. Hi, Satish from Hyderabad. Hi, Glenda. Hi, Nikhil from Bangalore. Hi, Ricky B from Nashville. Hi, Gauri from Amravati. Hi, I'm a technical support and developer from Dublin. I did not get your name, but welcome to the webinar. Hi from Hong Kong. Isuru from Sri Lanka. Shravani from India. Nitish, senior engineer, Bangalore. Joe from US. Hi, everyone. Hi, Sheikh from Hyderabad. Hi, Duncan. Hi, Mario from Detroit. Hi from San Francisco. Satish is joining us from San Francisco. Okay, all right. So Navya from India. So many wonderful introductions in the chat. I can see a few software engineers here. I don't see a lot of, yeah, okay. Hi from Ethiopia. Mehak from India. What you all do, you can tell us that as well in the chat. It's wonderful to see all of your responses. And I think it's time for me to start the webinar. Hi, Harshita from Andhra Pradesh. Hi from Nigeria. So, all right, it's a lot of responses in the chat. So thank you once again for sharing all of your introductions with us. It's great to hear from you. We have a global audience here with so many people joining us from across the world. And it's wonderful to have you all with us as well. And I'm so happy that you all took out the time to attend today's webinar, which is going to be a workshop for all of you. And this is going to be a really interactive and interesting session. So before we begin, I would also like to introduce myself. I'm Shweta, and I will be your host for today's webinar. We have a wonderful speaker join us today. I will give his introduction shortly. So like I mentioned earlier, we're going to build a live dashboard with Python and AI. And trust me, when I say this, you're going to walk away with some amazing insights as well. Once again, thank you all for joining in. Let's get to the webinar. And before we do that, let me quickly tell a few ground rules for all of you out there. If you have any questions, also because this is a workshop, please put your questions in the Q&A box. Or if you have any problems during the webinar, you can tell us in the chat as well. We will try to keep a look at have a look at the chat. But if you can't, you can, if your queries are not answered, you can post your questions in the Q&A box. Please use the chat box effectively, and let's keep the conversations related to today's topic and the workshop. I request all of you to refrain from sharing any external links in the chat. And I see a lot of questions regarding the certificate as well right now. So yes, you will be receiving a certificate of participation. For this, you will have to fill up your full name at the poll that we will be launching towards the end of the webinar. I hope all of this is clear for all of you. Yes, Gauri, we are providing a certificate of participation, but you will have to stay till the end of the webinar and fill up the poll to receive your certificates. All right. So with that, I'll quickly tell you a little about Simplilearn. I just want to understand from all of you, have you attended our webinars before? This is your first time. If it's your first time, you can let us know, or let us know by answering first time in the chat. If not, okay, all right. So many first timers. First time, okay. All right. Thank you, guys. Thank you for sharing your responses. Wonderful to see so many of you joining us for the first time. So I'll quickly tell you about Simplilearn. I'll just take 2 minutes of your time to do that. So at Simplilearn, we help learners transform their lives by empowering themselves through digital skills, and we do this through courses. We have helped over 8 million learners advance their careers across 150 plus countries, and we do this through global partnerships. And we have partnered with multiple universities and industry partners, universities like Virginia Tech, UCSD, and industry partners like Google and Microsoft. Today, we are going to be talking about the Microsoft-powered data science course as well, which we will talk about in detail towards the end of the webinar. So this is how we provide our courses, and some of the key highlights of our courses are as follows. So most of our learners have reported a 50% salary hike on completion of courses with us, and we have also been rated 4.8 out of 5 by most of our learners, which clearly talks about the kind of experience that you can expect through our webinars and through our courses. We also have a graduation rate of 80%, and in most of the courses, we see that a lot of people drop out after the first or second week. But one thing that we are happy about is this graduation rate. So we have ensured that most of our learners stay to complete the courses with us as well. And with that, I think I'm coming to the most important part of today's webinar, and that is introducing the guest speaker. And I'm very happy to introduce Chris Himmel. He's our guest speaker for today's webinar. I'll quickly give you an introduction. So Chris has spent over 20 years, that is 2 decades inside data, and not just studying it, not just reading about it, actually analyzing massive complex data sets, building machine learning models, and most importantly, turning raw numbers into decisions that change how businesses operate. He is a research-driven data scientist who's fluent in Python, SQL, R, and not just technically fluent, but in the way where he actually makes things that work in the real world. He has built predictive dashboards, optimized processes, and trained models that solve real business problems. That's the exact kind of thing we are going to do together in today's webinar. He is also a very gifted teacher, someone who has the rare ability to take something that sounds really intimidating or complex and make it feel completely within reach. And that is exactly why we have him today with us. And I promise you, by the end of today, you will feel what I've mentioned firsthand. So with that, everyone, let's welcome Chris Himmel to this webinar. Chris, welcome to the webinar, and thank you for joining us once again.
Yeah, thank you, Shweta. I've been around data for a very long time. I started in computers when I was just a kid. My dad was a programmer, so he got me in there. I was really young. Worked for him, doing programming, just basic programming. Got into data back in, when data really became exciting. I moved to San Francisco and just really, that's where the new gold was coined, which is data. That's what became so important. And I actually did some research in AI back in, my grad school in applying AI very early. This was like back in the 90s, before AI was really cool. And then when I switched over to like analysis, data analytics, data science, I guess it was last decade, that it grew from there. And, got into, just switched my career over from just pure programming over into data analytics, data science. Started teaching it with Simplilearn. Was a mentor for many, 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 many students. I'm always a mentor. Trying to get more people into this field, into AI. That's kind of where we are today. You guys are in the right place. Even if you have never done Python before, even if you've, starting from scratch, or have some experience, both, you're going to see some really good stuff today.
Thank you for that wonderful introduction, Chris. I'm sure everyone's waiting to learn from you. But before we begin, I would just like to set some context as to what we are trying to do in today's webinar. And I'm sure that most of you probably have built a lot of dashboards already. You might have had the charts, the colors, the spreadsheets. But the problem with most dashboards today is that they only describe the past. They tell you what happened yesterday, and they require a ton of manual effort as well. But today we're going to build something different. Chris is going to show us how to move away from that and start generating predictive signals. So we are going to build a predictive dashboard in today's webinar. So I hope all of you have clarity on what we are trying to achieve through this webinar. And with that, I'm going to start off with a very important question to you, Chris. I know that we are doing this webinar live workshop on how to build a predictive model, but why does this actually matter right now with data science and AI booming? How relevant is it to someone who's attending this webinar today?
Sure. So, yeah, whenever you're able to, do predictions, which is, we're actually going to talk about seeing into the future, predicting what's going to happen, next, not just look at your data and see what to do now. We're going to, base what we're going to do now on what's going to happen in the future. I mean, things, whenever companies apply AI in this way, it's like you four times, faster growth in their company. So much data we're not able to use, but if we can apply it, this gives us the reason to apply more and more data, to get better and at more accurate predictions of what's going to happen in the future. Um, yeah, I mean, today, within 60 minutes, very quickly, you're going to see how we can predict into the future, and not just, not just me up here doing it, but I'm going to have you guys doing it. So, in today's session, by the time you walk out of here, you'll have your own, predictor, which you can then apply, your own data. So I'm going to give you all the tools and know how to do that.
Um, Thank you for that, Chris. So, like Chris mentioned, we'll just quickly tell you about the tools that we are going to be using in today's webinar, the kind of toolkit that you would require. So, Chris, before we dive right into the workshop, could you give them an overview of what the tools are that they'll have to use during this workshop?
Yeah. Well, I mean, it all bases around Python. That's the language that we're going to use. And there's several ways of running Python. VS Code, is a very good tool. Any developer, works with VS Code, and you can get Python just running on your own machine. Google Colab, though, Google makes available a free platform for running Python. And that's what I'm going to push you guys to do, show you guys the steps on how to get your own collaborative environment going up on Google Workspace, and then you'll just be running it yourself without having to install Python, install Visual Studio Code on your own machine. But I'm going to also show this running there as well. And the technology behind all these, forecasts, these predictions, we're going to use a tool that Facebook has made available to us, Facebook Profit. It's a model and algorithm that they have put together. But you're going to learn about this. When you take the class, you'll learn the technology behind this. The class we're going to talk about, the Microsoft's data science course. The algorithm, how it comes together, and I'm going to talk about it some, today. What's going on behind the scenes in this Facebook profit model.
Thank you for that, Chris. I would just like to address two questions before we get into the workshop. I see a lot of questions about the recording. So I just want to let you all know that you will receive the recording, but you will have to fill up the poll that will be shared with you towards the end of the webinar. You can fill your full name and you will receive your certificate of participation, the recording, and the slide deck as well. So with that, I think, Chris, I have answered a lot of the questions. It would be great if you can share your screen and start the workshop. I'll quickly stop sharing my screen.
Right. Yeah, and I'm looking at the questions there just real quick. Couple of them. One is which version of Python? The version that I have running on my machine will be version, was it 3.12.9? Just because that's the version that I'm running, a bunch of other stuff on, like Agentic AI. Some of the latest in LangChain, which is Agentic AI, it doesn't run on any newer version than that. But yeah, that was one question. As far as what's running on Google Colab, I'm not sure what's I would have to, just do a version to see what's running on there. But you're going to be running it as well, whatever default version that they use. And you have a question, I guess, Herv, VS Code versus Python. You run Python, you run a language within VS Code. VS Code is a development environment. Um, and then you run whatever language within that Visual Studio Code, and we'll just be running a Python notebook, within VS Code. See if there's any other quick questions. Okay, so somebody's using 3.13. That's a little bit later than what I'm using. It's fine. Um, so which version of VS Code? I just use the latest version, whatever you download from Microsoft to get VS Code. Yes, we're going to do a IPYNB, a Jupyter Notebook. So there you go. 311 is okay. Any version will work with this. All right, so let's get started. Let me share my screen. And all right, so where are we at here? Let me get this out of the way. Yeah, down there's good. Is it? Okay. All right, so I mentioned Google Colab. If you look here on, here's my Jupyter Notebook running, locally, and okay, there we go. So um, this is my notebook, running on Visual Studio Code, but we're going to be running it on Google Colab as well, and I'm going to walk you through how to get started doing that. So the very first thing, and I'll probably be posting this up a lot, is getting going with getting the data or the environment down. The notebook, which is sitting up right now on um, what do you call it, on GitHub, which you can download. So this is the to download it. Trying to think of the best way to get you to download it. Does this work? Now, just basically, you want to go to this site, this URL. I'll post this in the chat. And if you guys can continue to repost that so that everybody is able to get it down. And as we go a little bit further with this, I know people are going to go at different uh, different speeds. We are going to take a break and let everybody catch up, but I'm just going to power ahead and see about see how far we get. Um, all right, so to download it, once you go to that site, you just click out here on, download zip, and then within Chrome or whatever browser you use, it will download it, and then you want to unzip it. So here I'm on a Mac. I just double click on it and it unzips it, and I already have a copy of it here. So yeah, so now you have the Jupyter Notebook. Um, okay. Oh yeah, that's the old version. Here's the newer version. Um, so the Jupyter Notebook, the data, which is quite large, and the banner here, README. So all of that's if you've done this, you have pulled it down. Um, Let me make sure that. Um, okay, so there's nothing to be installed. You just need to click on this link and download it. As far as RR0760. Don't install anything, just download this. So Now, the next thing that you want to do, everybody's got Gmail. So if you go to Gmail, and I'm just going to start over here, uh, go to your Gmail. We're going to basically get Google Colab started. So here's my Gmail. I'm going to switch over to Google Drive. And this is where you're going to put uh, your Google Colab, where basically what you want to do is upload into Google Colab, and this one has a lot of stuff in it already. I'm going to switch to another Gmail just so uh, it's a little cleaner. Okay, and here is basically everything that I uploaded is all just right here. Um, and I'm just going to remove it, and we're going to start over again. Move to trash. Okay, so I downloaded this folder, and basically I'm just going to take it, drag it onto uh, Google Drive, and let's see if there's any questions. Okay, yep. Okay, so the first thing to do is click on this link. You can click on it from the chat. That's the first thing to do. So then I'm in GitHub, and this is what happens when I click on that link. And then you click on this code, the green button here, and download zip. So I want to make sure everybody's gotten that far. Once you've downloaded the zip file, um, that I now have another copy of it. If you're on a Mac, double click on the zip file. If you're on a PC, I think if you right click, you can expand it, basically. And then you have the folder. So, so those are your steps to start with. And then we're going to open up a nice clean Google Drive, but it really doesn't matter, what, Google Drive that you use. You can get to Google Drive from your Gmail. You just click on these 9 buttons and go down to Google Drive, and that will get you there. So, okay. So now that we have this up on Google Drive, what I'm going to do is go into that folder and then find this Jupyter Notebook. This is the Jupyter Notebook uh, in the Google Drive. In this is where all the code is. Now, getting Google Colab installed into your Google environment is a little bit tricky, but I've got a shortcut. If you just try to open the IPYNB, okay, I already have Colab environment installed, so it goes ahead and opens it for me. But for you, it may not do that. It may give you a message saying, uh, you know, do you want me to install it? Something like that. Um, so how do you want to open this? Is that what you guys are seeing? On Windows, just exit through your browser. Yes, you could do it that way. Yes. Yes, on Mac. Okay. So once you have the Colab environment installed, then when you open it, it basically opens up Google Colab, and you now have this Jupyter Notebook open where you can actually go and run it. Can you do this on your Android phone? I have no idea if you can. Really, this is meant for doing it on a PC. You might be able to do the steps that I'm going through on there. Probably, yeah, probably it works. I just have never done that. How to open that folder on the drive? You just double click on it. All right. So, okay. After uploading the folder to the drive, you open the folder. Here's the folder. You may have a different name, no two on there. Just double click on the folder. That brings you into it. So if you want to know what's in here, um, there's a data folder which has a data.csv, which is the data itself, and we're gonna look at the data. Yeah, before you upload it to the folder, unzip it. Yes. Yeah, upload the file to the Colab. Upload the folder to into the Colab environment. Okay, we'll give it a couple more seconds here. Just gonna kind of push forward. I've got it open here. Oh, this is the older version. Let me close that. This is another drive. For some reason, the banner is not showing up. It should be because it's right here, but it's not. I don't know. Some things with Google Colab pointing to files that you have there don't work so well. Um, if I open this, locally, then it does show me that banner. But basically, I've got it's a nice description of what's going on, what I'm going to do. I have that in um, my first what's called a markdown cell. A Jupyter notebook is organized in what are called cells, and you run each cell separately. And basically, it's just like running code step by step. And the way they actually run the code. So I don't want to run all. Um, it's interesting. I just run selection. So I just do Shift Enter to run one particular block. I can do run all, but that runs everything. So I'm going to actually stop it. And connecting. Oh, connecting. So the first thing that Google Colab does is it gets a process running underneath, a process running that runs everything, and it tells you how much RAM and how much disk are available or are being used. There are lots of interesting things, a lot more things that you can play around with Google Colab. But yeah, I'm just going to run one thing at a time. Oh, and here we go. You click on this little red arrow here to the right to actually run this, and I interrupted it. That's why it had that nasty message down below. Um, so everybody good so far? Okay, where to open Google Colab? Okay, so the way I opened Google Colab was by double clicking on the Jupyter the notebook once I uploaded it. You just double click on it and it will say, do you want to open this? Let me get that message going here. Let me look at, is it? No. Okay, search Colab. Once I have it, okay, I'm gonna uninstall it. So once I uninstall it, then now I have a clean environment. And if I double click on it, oh, it's going to install it again because it already knows. Okay, so I didn't really uninstall it. Okay, well, you get a message and that gets, and then you can install it from there. How did you upload to the Google Drive from downloads? I just dragged it onto Google Drive. So here's my drive. I've got a folder here that I've expanded. Just drag it over. That's how you do it. There is another way to upload. Let's see, what is it? File upload. You click with the right button and then file upload. That's another way of uploading or folder upload. Yeah, then you can do it. But I just do it simple way. Just just drag it over. Okay. So let's go ahead and keep moving here. I'll keep an eye. There's no open with Google Colab option. You don't open it with Google, just double click on it and it just gives you a message. Um, okay. So now I'm going to explain, some of this code here. Kind of started from the top. Something in Python that you always do, and actually a lot of languages you do this, is you import a bunch of libraries. These are a bunch of black boxes. These are the tools that you use within Python to do things. Other people have written this, um, all of this code, all these tools, uh, and uh, now you're going to go and use them. So like pandas is a very popular one for dealing with data. NumPy as well. It's a numerical calculations. Here's this Facebook profit. That's the language that, or that's the tool that we're going to use for predicting. This features, I don't think we actually use this one. There are sometimes you pull in a library and then don't use it. We're going to create, we said we're going to do dashboarding. Um, and that means creating visuals. That's what it means to me. And Python, gives you some visuals that you can, uh, then that you can have access to. And that's all within this matplotlib and Seaborn. Those are the main ones. Um, so we're going to create some graphs using those. Scikit-learn, this pre-processing, I don't think we actually use that. I don't think we use this mdates either. Um, so some additional points or libraries that we're pulling in within Profit, add change points to plot, just some extra stuff, basically. And I'll show you this stuff once we get to it later on. All right, so when you run it, then it gives you a little number up here saying that it's run, that I have, all this stuff loaded into memory. Okay, so Profit is not a module. It's a library. Um, if you, oh yeah, I can make things bigger. Yes, thank you I forgot to do that. Um, okay, so yeah, so once we have all these libraries loaded, then we're going to load in our data. Now, there are several different ways of getting the data, uh, from, wherever it is from the disk into memory. Because what we need to do is get it into this Colab environment so that we can work on it. And there are several ways. If I'm using a local environment, then I have the data, and I'm going to show you that over here. I've got the data just sitting in a data subfolder, data and then data.csv. So that's how you would load it in. And what I'm doing here is something fancy. Basically, I'm setting this up to load the data from several different places all at once, depending on which environment I'm running it in. What I do is a try and accept in Python. So what I'm going to try something, and if I get an error, I go down here. So what if I basically I'm running this from Google Colab import drive, and if I'm in Google Colab, if that's the environment, then this works. If it doesn't, it errors out and it jumps down here. So I'm in, but I am in Google Colab, so it's going to do the code in here. And what I said was, if I'm in Google Colab, just go pull the data directly from GitHub. And this is the way you do it. I have the data in GitHub. And what I did is I created a URL that points to that data in GitHub. So if I go back to GitHub, I have a data folder here. Here's the data. This is the URL, but if you're actually pulling data, you need to add a little bit more to the beginning of the URL, to the domain. This raw GitHub user content instead of just GitHub. But other than that, the rest of it's the same. And you just do this Python pandas command to read that data into memory. Um, okay, so I still have this question, how to download and upload onto Google Drive. So to download it off of GitHub, and when you say download, you mean the whole code or you mean just the data? So the whole code, you just, in GitHub, you download, um, you go to that link that we're posting, and you go to code and download zip. And then you open the zip, and then you drag it into Google Drive. And there is a way to pull the data in directly in through from Google Drive, and this is a way to do that. You mount the drive and then you read it in. You can read it in that way. So this is, there's two different ways. I just chose, for this case, the easiest, which is just get it directly from the URL. If you're using a VS Code, is it good? Yeah, yes, you can use VS Code. If you know how to run that environment, then yes, by all means, run it that way. Okay, so I'm going to go ahead and run this cell. I can click on this little play button or shift enter, either one. It loaded the data in, gave me some messages. Sometimes I get warnings. It's only a warning, so I'm fine. So something you always do whenever you load in your data, whenever you have a data frame or have done some work to the data frame, is look at it. Look at the data. And this is a great way to do it. We called this data frame DF after we loaded it in. There's several ways of looking at it. The way to look at the first three rows is this. df.head, and then give me 3 rows. So now I'm looking at this data, and I can see that there's lots of columns for this data. It doesn't tell me how many rows there are, but if I take off if I just do df, this is kind of the nicest way to look at it. I see the first 5 rows and the last 5 rows, and it tells me how many columns and how many rows there are altogether in this data. So this is, it's 500,000 rows of 27 columns. And, what kind of data is this? What is this problem that we are working on, that we're solving here? What kind of predictions are we going to do? So looking at this data, what we have is like a development, we have a borough, we have an account name, location. So this is all usage um, of ooh, didn't want to do that. Usage of power usage for a particular month, um, by by person, by account name, Adams. And there's a lot of records for this one person, Adams. Actually, it's development name, so maybe these are all developments. However, if we go over to revenue month, we can see that these are different months. So service start date, end date. Um, Let me scroll over. Uh, we have meter number, estimated, no current charges. Okay, so here's how much power they used in that month. Lots of other stuff, lots of information. We don't need all of this, even though, as an advance, we might want to use this other stuff. But right off the bat, a lot of this stuff we don't need. Number of days, that's going to change by, start to end date. Other charges, a lot of stuff here. So it's always good to just look at your data, get familiar with what's there, and and that's that's basically what we're looking at. The data that we're looking at. You just want to become familiar with it. I'm going to go ahead and change this back to df.head 3 so that it's a little easier for me to move back and forth. Um, so I'm going to pick basically uh, well, eventually what I'm going to do, I guess we'll get to it. We'll get to it. I'm going to do some data manipulation first, which we'll talk about this later in the summary. But what you do first, once you have the data and you're looking at it, is clean up the data. Get the data into the right format for your problem. You might have missing data. You might have data in the wrong format. Here's, I've got dates here, but then I have this month, revenue month. But for us to do predictions, we need to have that in a date format. So we don't need all these columns, so we're going to cut it down. So all this kind of data manipulation that we would do, this comes with experience and understanding your data is, getting to that. So a couple of interesting things we could do right off the bat is instead of have this in order by account, let's put it in order by date, just as something interesting. So this is the way you do it in Python using pandas. I've got a data frame, which is just like a table of data, and I'm going to sort it on one of the columns, this revenue month. So before I had, revenue month going up. Once I sorted it, now I have all of my, 2010-1, January 2010 being the first month. You mean in the first, top of the table. So yes, eventually we're making dashboards. We're making graphic representations, which we can pull into a dashboard. Okay. All right. So something else that we need to be able to do is instead of having it just like this, this is actually just text because it's not an actual date. We need to convert that to a date. We can use this formula to date time. And what we're going to do is we're going to take, this is how you do it in Python, is we're going to take that column and we're going to run it through this formula to date time. So it just, this formula knows that if it's in a year dash month formula, then give me a date and give me the first day of the month. And then we're going to replace that column with that new information. That's what this basically means. So I'm going to giving you some basic Python commands. Um, walking you through it. So instead of now 2010-01, we now have, actual date here, in date format. So we've done some data manipulation. Um, that's the way you can do this. Okay, and Xiaowang Lo, I can fork your repository, run it by own code space. Yes. We'll first load the data by reading CSV directly under the data folder. Right. Yes. Right. Yeah. Whatever. There's a lot of different ways to do this. There's so many ways to skin the cat. Python is so popular that, there's so many different ways of running it. So many different data environments. Okay. So I've done some data manipulation. You would do a lot more if, if you had the time, if you want, I'm just going to do some basic stuff to start with, kind of get to the meat of this. But, this is where data scientists, data analysts, they spend a lot of time, manipulating the data, making it better because all this data has information in it that can be used for prediction, has additional information for it. All right. So as of now, what I'm going to do, I'm going to cut my data down to a very, very small set of data, and just do some predictions on that small set of data. What I'm going to do is I'm going to take my month or my revenue month, which is now a date. I'm going to take, how much power was consumed. Where's my consumption kilowatt hours? Oops. That column. And what else? The borough? Yeah, and the borough. So I'm gonna create another data frame, DFM, that is just those three columns. So let's look at what that looks like when I run it. So yeah, I dropped all the other columns, and now I'm just down to three. And now what I want to do is I want to start plotting this. I want to create some visualizations because, this data, I see first three, but it doesn't really tell me much about the data. But let's do some visualizations. Okay, so here's where I'm creating a plot. Now, creating a plot, there's a lot of different ways of doing it, and I'm just going to kind of walk you through, this first method. We're going to have several different types of plots we're going to create, and they're a little bit tricky, but what you want to do is just copy and paste, and just kind of get a general familiarity, with this code. Creating the plots from scratch, is kind of tricky. So you just basically, copy other plots and add to it. So plot is actually part of the data frame. Uh, and so you basically pass in, so we have the data, we're showing the data. So what you do is you pass in certain parameters about the plot, and then, it just basically out comes a plot, based on these different things. So what we do is we say, I want the X of this plot. I want to, first of all, I want a scatter plot, dots, a dot for every spot that I want plotted. The X of that dot, the X axis is going to be revenue month. The Y axis, vertically will be how much was consumed. So I'm going to spread out my consumption across all the months that I'm looking at, all the dates. I want it to be 10 by 5. So this is, 10 inches by 5 inches. And that's all relative depending on the size of your screen, but it gives you an idea of, the aspect ratio of the size. MS equals 1. I forget what that is. I think that's like how big the dot is. Um, I want the color palette 0. I set up a color palette up here, from Seaborn so that I can, pick a bunch of different colors, a range of colors, and this is how you pass it in. Um, and basically it's the what do you call it? The borough is going to be the different colors. Um, okay, and going to give a title to this as electricity consumption. So you just run it. All right, here you go. Okay, so we can see here that our dates, our revenue month ranges from that beginning of 2010 all the way through, end of 2022. But we're missing data, missing 2011, missing 2018. So that's kind of a hole in this data set. So we won't have that data to work with for this, but it'll still work even if we're missing data because we have a lot of other information, a lot of other data. So you can see that this is where our consumption values are. They range, a lot of them are low values, but we have some outliers, some high, this is like millions is what our x-axis, our y-axis is. And we picked y-axis to be consumption. Um, so, we have lots of consumption values. So it kind of gives us an idea of where what the data looks like. We got to start doing that as soon as we can with the data. Got a few outliers, which we could screen out those outliers. Like we may have one guy, which might throw off our predictions. We're not going to predict anybody to have this, so why would we include it? Which is something we could do as part of, our code. So there's a lot of data cleanup like that we could do. And also we could fill in these values. That's something you often do with data. Which will be the target variable. We're going to predict. So we're going to predict consumption into the future, basically, is what we're going to do. That's why we picked that column. All right. Okay, so now I'm going to do another plot. I'm going to plot each borough. So I'm going to go through the list of boroughs, and I'm going to plot in a different way. So I'm going to use a for loop, go through the data and filter down my overall data frame just to the one borough. Uh, so first I create a list of boroughs. So if I take that one column and do a dot unique on it, now that's what I have for boroughs. And this is the way you loop through each in the list of boroughs. Oh, let's see here. All right. Uh, okay, what time do we have the break? All right, so let's go ahead and take a break now. We're coming up on an hour. We've got started. Let's let people catch up, and let's go ahead and just take a 5-minute break. And yeah, we'll just continue on from here. We're getting into the meat of this for the predictions, but we're still exploring our data. This is called data exploration. So yeah, let's take a 5-minute break and then we'll come back and continue. And just keep putting your questions into the chat, and I'll jump on it as soon as I can.
Yes, like you mentioned, let's go for a 5-minute break. I hope all of you will be back by 7:58. And for everyone who is asking us how long the session will be, this is a 3-hour workshop for everyone, and there will be a Q&A section towards the end. And I understand that all of you are sharing all of your questions, but try to follow along, and we will try to answer your questions towards the end. I hope all of you are back from the break. If you're back, you can let us know in the chat, but you can just give us a thumbs up. All right, all of you are back. Well, I think let's wait for another minute. In the meantime, I'm also sharing a link in the chat. This is for our Microsoft data science course. If you are interested in data science, if you are interested in building dashboards that function effectively, also because you have joined us as a part of the webinar, please do check this out. This is delivered by Simplilearn in collaboration with Microsoft. So it's a very credible certification for all of you. And we are also covering a lot of projects and capstone projects, industry projects as well, which we will talk about in towards the end of the webinar. So for anyone, I also saw a few of you tell that you are beginners in the field of data science. So probably this could be helpful for all of you. So do check it out if you are interested in the course or in any data science course. Please do check it out. So I think with that, Chris, you can resume the webinar. Everyone's almost back.
All right. Just looking at the questions. I was able to open new notebook and able to run that. Okay, good. Which plots are necessities for EDA on the data set? There's so many different types. And what I'm trying to give right now is some basic plots, just kind of throwing them up there so that you can have, some to look at, some different, ways to do it. But, I don't really, I'm not really going to get into how they're built. I'm going to explain the parts of it, in the code. But, but yeah, I mean, that's a whole class. I remember teaching that class is visualization. So many different types. Histogram is, a huge one. Scatter plots, line graph. There's so many. I mean, this is a histogram that I'm showing here. Sort of. Um, it's showing the sizes, by date, not just how many. Um, but yeah, actually it's a scatter plot, but it has the effect of a histogram. But this one is similar, but we're just breaking it down by borough, showing each borough, separately. Uh, and it's just a completely different way, of setting up the plot. This is I'm doing a plot.plot versus before I did a df, data frame.plot. So yeah, and I'm cycling through each borough and showing each one of them separately. And the practical implementation, I mean, all of this is practical implementation. I'm going through each step of, getting the data ready is where we're at now, and exploring the data. That's all. You have to do all of that in any data science exercise. You're going to do that. And you're going to spend 90% of your data sometimes doing that. And you'll see once we get to the actual predictions that if we did this right, then we get predictions. So I'm going to go ahead and run this, and we're going to see for each plot, I mean for each borough, showing a different plot. Which data set am I referring to? The data set that came with this. Okay, what's going on? Why didn't it run? It's because all I'm doing here is defining this as a function. I now have to run the function. Okay. So let's look at what came out here. I'm going to scroll up to the top, plot borough. So I'm running this function that I created up here. Sometimes when you have a bunch of code that's, together that you might run more than one time, you create a function out of it and you just run that function. So here is the Bronx plot, and looking at the code, I said plot the revenue, that's okay, that ends up being the Y or the X comma Y, and give it a label of what borough is it. So that's the label is Bronx. So the first borough is Bronx. I'm plotting the revenue month across, that's the X, and the Y is the consumption. I'm giving an X label and a Y label. I have to specifically tell it that. Here's the X label and the Y label. And then I'm giving it a title, whatever borough I'm on, showing that, and the word plot. And I'm showing a legend, adding that in. So I've got a Bronx, and I can see that those go up to like a million, average somewhere in here, 500,000. Brooklyn, it averages like 200,000, so it's a lot lower. Uh, Manhattan, it's about the same as, the Brooklyn. Queens is much lower. 250,000 is my average down here, but I've got an outlier here that kind of condenses everything down. Staten Island, so just getting an idea. And then I also have this non-development facility for a borough, NDF. So this we can just kind of skip over. We even have data for every year for that. So this FHA, it's another one, not as much data there. Okay, so I've got missing data. They're missing values for some duration, so I'm just kind of seeing that information. Um, okay, so now I'm going to show a different plot. And the way I'm going to do this plot is I'm going to condense it all so that, I'm just going to have the month be what I plot against. Month of the year. Here I've got the whole, month and year. But now I'm going to look at it I'm going to create a column that is just the month. So I don't even show what X is here. So I'm adding a column. First, I'm creating this new data frame X as a copy. It's not even a copy. It's just a pointer to my original data frame. And then I'm adding a column that is what month it is. So you can see that this month is January, so I got a month one. This month also is January, so that's all I'm seeing is January in this. It's just coincidence. Um, but yeah, so it's the same data, but just now showing by month. And now I'm gonna uh, show what that looks like. And I'm dropping any rows that have NA, that have missing data. Um, and I'm going to do this cat plot, and you'll see what it looks like. It's another type of plot, not just plot, and it's something that's in Seaborn. We're just showing a different plot, and it's easier to explain once I actually show the plot. So let's go ahead and run it. Takes a minute to run. So my X, going along the bottom is month, and my Y, how high I'm going is consumption, just like before. So basically, this is what I end up with here with a cat plot. It's a categorical plot. So all my categories are each borough. Hue is borough, so the different colors is how I'm setting that. And the how high is uh, the consumption, and then going across the bottom is the month, the new column that I created month. and height is 5, aspect is 2. So it's just that's giving you how big is my graph going to be. Uh, and that's about it. I dropped, any time I've got missing data so that it doesn't blow up my graph. And I have a nice label set of labels here as well. So Bronx is blue, Brooklyn's the next one, Manhattan. We can tell very quickly from this, who are the biggest ones because we put them all next to each other. When we showed the different ones this way, different boroughs this way, it was hard to see which ones are the biggest. But looking at it this way, I can see which ones are the biggest and which ones are the smallest. I can see that the orange one is the smallest. Orange is Brooklyn. So Brooklyn has the lowest average for some reason. And then the blue one, Bronx, they end up with the biggest. So it's kind of interesting. Um, yeah, and then this FHA is really small. A lot of this brown one, this non-development facility, don't know what that means. It's just part of the data. Probably want to drop that data, drop that part of it. Okay. Okay, so we got a problem here. Name profit is not defined. Module was not loaded initially. Any alternative? No, you need to pip install profit. Um, I'm not sure what environment you're in, but you need to get profit in there. So if you don't have it, then you've got to install it in your environment, and pip is the way to do that. Um, this is where potentially if I didn't know how to just pip install, then I would Google the error message and it would tell me. Yeah, thank you, pip install. And you can do it within the notebook this way, just putting a percent sign in front. That will run it. Actually, exclamation point pip install profit. Is it free? Yes. Everything I'm showing you here is free. Um, So yeah, try that. HH, Ski, try this. Oh, you're using data equu modules. So it just doesn't have it installed um, by default. Okay, so this is another graph, just kind of getting to know our data basically. Highest in the Bronx, followed by Queens. You know, something that might be, interesting to look at is population of all your different boroughs. This is another thing to use potentially. All right. Okay, so the next thing we're going to do, now we're getting into the meat of prediction because we're going to start our predictions with just predicting New York as a whole. What is the consumption, going forward? So I'm going to create a data frame that I'm going to average the consumption for each month um, for New York. So January is going to have an average consumption. February is going to have an average consumption. For and by year 2010, we're gonna have a what's called a time series signal here, a time series, which basically is just like the stock market. What at this time the value is this. At this time the value is this. So this code right here, this group by takes, I'm going to take the average of consumption, grouping it by revenue month. And then I'm going to simplify my column headings, convert revenue month to DS and consumption to Y. So if I do that, what I end up with is just 132 rows, 133 rows, sorry, because it starts with 0. 2 columns. I have a date, which is my month, first day of the month, and then my average consumption for that year and month. So that's, I'm simplifying my data down to something very easily predicted. So what I'm going to do right off the bat, once I have this, is graph it. I want to see what that consumption looks like. And I'm just going to plot my consumption, which is DS, my average consumption by, I'm sorry, that's my month, my date, and my consumption is going to be the Y. So I'm going to plot those um, and then add a label for the horizontal and a label for the vertical and give myself a title here. And this is what it looks like. My average consumption over time. We kind of saw this pattern back here when we looked at by time, the consumption, but instead of just looking at each consumption separately, I averaged them together. Here I can see I've got some high ones in the middle of every year. And as you can see, like during the summers, I've got spikes and then low, like in January, kind of like that's kind of what I'm seeing here. So this is our signal that our average consumption. And what we're going to try to do is predict this. I want to know what's going to happen in the future, not just what's happening now. And we can see there's a pattern here. First pattern is we kind of dropped over time. Our average consumption dropped. Maybe our heaters are more efficient over time. Um, okay, for some reason the GitHub, I'm not sure why the GitHub would not be working, but go ahead and send it again. Here's the GitHub. Um, but yeah, so that's one thing. And another thing is our seasonality, our seasons, going up and down, for consumption. We can see we have a spike, big spike during the summer, and then a little spike, right at the end of the year, I would say, like in December or January, it goes up again. So that's what we're going to predict. So how do we do that? This is a very typical data science problem, is doing this prediction. So anybody that's done any work in data science up to now, they have heard of this train test split. So what we're going to do is we're going to divide our data set into two sections, where we're going to consider the past and then where we're going to consider the future. But we're going to consider this as of 2 years ago. And this data only goes through 2023. So 2 years ago is 2021. We're going to take all the data before that, consider the past, and all the data in front of it, the future. So we're pretending like we're 2 years ago and we're going to predict the future. We already know what the future is if we were back then, because we're in the future now, but we're going to pretend like we don't know it. And then we're going to, from all the data before 2019 or before 2021, we're going to use all that data to predict the future. And then we're going to compare it to what was the actual future. Okay, so Fiati, yeah, this is something, it's kind of key. So, I'll explain it again and then we'll start doing it, and I think you'll get it, if you don't have it yet. So we're going to split our data, our time series data, into two pieces. We're going to pretend like we're 2 years ago. Okay. And then use 2 years ago, what would have been the past from 2010 up to 2021. We're going to use that data to predict 2 years into the future. And then, now that we have 2 years into the future as of then, we can compare that to what was the actual 2 years in the future, because we have that, because we were just pretending. Um, so that's what we're doing. We're cutting the data into two pieces. Everything before 2021, and then everything after 2021 and beyond, we're considering that we're putting that into a different data frame. Um, so are we going to cover concept of k-fold, stratified k-fold, leave one out, etc. for train test split? No, we're not going to do that. Those are for different types um, of not predictions per se, but interpolations. Those are different. That's a different type of data science um, exercise. We're doing it differently. We're doing a different exercise, which we don't use those concepts, but those are in the in the class. The link. Okay, which link are you asking for? Because I put the link out there before. Um, why did I choose 2021? Because it's like I want 80% of the data to train and then like 20% of the data to test. So that's why I'm splitting it that way. And it's just rough numbers. I could have used any other year, but I want, generally most of my data for training and then for testing, to see how good I train. I want that in the future. I want that to be a smaller amount. So once I do this train test split, now I've got my data cut into two pieces, and I'm going to plot my training set and my test set next to each other, doing a merge, taking my test data, I'm merging onto it my training data, and then say plot it. Okay. Um, and this is just a nice quick way to do that. So here I just spliced it together using that merge. And I renamed all of those columns to be test set, and all of this data is training set. So it's just a quick way of putting the data back together just to show it. All right, so now that I have my data already, I'm now going to employ Facebook Profits to train on that data and also to generate my predictions. So how does Facebook Profit work? Let's go into that. First, any other questions? Let's dig into this neat Facebook Profit. There are simpler ways of doing it. There are other libraries for predicting. There are more complicated methods of doing it, of predicting, of doing these kinds of time series analysis uh, projects, the different algorithms. So, Facebook basically created this and then they made it available. It's open source. So you could actually change it if you want, make changes to it, make your own version. It's great for seasonal effects. Like, here we've got seasonal effects. Trending, this is trending downward. So it's great at picking up those types of um, aspects of your data. So great for sales, predicting traffic, demand. Those are some of the applications for this. Anytime you have missing values, it just kind of interpolates. So we're missing some data. So it's great for, getting around that. And it screens out outliers. It's very good at doing that. Okay, so how does it work? What's the theory behind this Facebook profit? This is really what it does. So any data, any time series. Let's see, are we going to cover any regression models? Uh, this is a regret. This uses regression underneath the covers, but we're not going to talk about, how that happens. Um, those are more for like interpolation type of problems than time series modeling type of problems. Uh, so, so yeah, so this model, what it means is, okay, I break my signal, which is my consumption, break it into several pieces, a G, an S, an H, and an epsilon. So the G part of it is a trend. So long-term growth or decline. We can see we have, the data going down and eventually, kind of settling. And then we have an S, which is a seasonality. So seasonality is okay, a rhythm within that trend. So if we take out the trend, then we end up with seasonality. And then we have special cases happening, holidays or events. So if we have any breaks, like here we have an event of no data. So that's another part of the signal that Facebook Profit pulls out. It basically separates your data into all three of these. So, if you knew all three of these, you still are not going to have your signal perfectly because it's real life. We are predicting something that's happened in real life, and real life doesn't have an actual formula to it. It does, but it's so complex. So what we do is we say, you have all these three things, but then we're going to add on to it this random noise so that it's real life. Real life is not, it has this element of randomness to it. Okay, so somebody's saying my voice is not clear. Is there an issue with the transmission or whatever? Let me just check my.
I think your voice is clear. If anyone's having a problem, please check your internet connection because it's audible for everyone else.
Okay. All right, just checked and it looks good. Okay. So this is the way profit works is it does some calculations to come up with these different formulas, these different aspects, pieces of the data of your time series, and then you add them all together to get your final uh, your final signal. And this epsilon, this random noise, that's just a part of it. You don't actually model that. It's just random. So, all right. So what are how do you define all of these? The trend component, the G, it's either linear, so a straight line increase or decrease, or logistic, which means like it exponentially drops. That's it has that kind of uh, aspect to it. And then change points, so maybe the trend changes. So it can predict that. It can, it can change its, not just have a one particular trend for um, the whole signal, it can change. And we'll see how when we run this, it does that. All right, then there is seasonality. So we either have a weekly, yearly pattern, daily pattern, a lot of different, monthly pattern, so whatever seasonality, it can calculate that. So like a sine wave, it adds that to it, and whatever the frequency of that sine wave, uh, that's what it'll calculate. So okay, and then you can basically this is a manual process adding in, okay, what were holidays? What are days that we want to make sure that we highlight as not not being part of the overall the rest of it, the trend and seasonality. So they need to be calculated separately. And then this noise, which is just randomness. Okay. So any questions so far? The next part, I'm just gonna, give a little bit. Well, let's jump over some of the more details and actually get into running this because it's just talking some more details about it. We're just gonna go through the more details by actually running it. Again, trend, we have an overall trend for our data, then we have some repeating patterns, and then we're going to manually add in some official events. We'll see that. And then the last thing is that noise aspect, which is just the randomness to make it real. But we don't actually model that. We just say that we take our model and we add in noise to get uh, our real signal. Okay. All right. So any more questions about that? All right. So let's go back to our problem. We're going to train the data. This is what our training data looks like. We have, 108 data points. If we go back to our graph, all this, the orange from 2010 through 2021, if we count the number of points we have, data points, we have 108. So I'm just kind of showing that data again. And this is the Y, the up, how high, how much consumption. All right. So this is the way that you employ profit. You say, okay, I want a profit model. And this variable holds that model in it. So all the definition of the model is in there. What I want to do with this model is I want to fit it. Yes, we're going to tune the parameters. We're going to do some parameter tuning. Um, but right off the bat, we're just doing a base model. No tuning. So right off the bat, I'm gonna say, take my model, my Facebook profit model, and this data that I have right here, and learn it. Train on that data, fit to that data. So once I have the model, now it's not just a dumb model that is, just has all the formulas in it. It now has learned, that set of data, the New York consumption by month on average, for 11 years. So once we fit to it, now we're going to run this uh, instead of fit, now we're going to predict, make future data frame. That means predict based upon them, take the model and predict based upon that model. Give me 25 frequency of months. So, so give me 25 months of future data. So start with, 2021 0101 and predict it. Um, so so first I create a data frame and then I predict and stick those values into a forecast. And let's look at what that forecast looks like. Okay, so I just now did the fit, then I created a space for putting the future data, then I put the future data in it using predict. And this is what I came up with. If I just look at the first 5 predictions, um, Okay, so it's actually predicting even back to, in the 2010. It just doesn't go into the future. It actually goes back to 2010 and predicts. Uh, let's see. Let's do this other one first. Um, so I'm going to start doing it this way. I'm starting in 2021, starting going into the future. So now I have uh, all of these different values, and the one that is the actual prediction is the y hat. So this is what I'm going to predict um, into the future. What consumption I'm going to have in those future months. And what it does is it breaks down my that future value into several pieces and shows like a range for my future value. Like how sure am I about the future value? So y hat is the prediction. That's what y hat is. So I've got a range for that prediction. So I'm like 95% sure. I'm not sure what the lower and upper first do, but I'm 95% sure that my future is within these values between 2,500 or 25,000 and 30,000. And I've got a trend, so that's that one aspect of it. Um, not just what is my prediction, but what is the trend? Because then I add to it uh, a what do you call it? A seasonality. So okay, so it looks like a turned off seasonality. So we'll add seasonality back in later, I think. Interesting. So I'm not sure why it turns it off, but anyway, so that's what we have for our first prediction. Now, just to show you the future predictions, I went ahead and only predicted for the future. But what I'm going to actually do is predict also for those past values. And I'll show you why in a second. I'm going to plot basically the two values next to each other. I'm going to plot the actual and the predicted, the forecast next to each other, which is this. So the dots themselves, and this is a plot that's just a part of the model. It's not, I'm not creating a special plot, which I'm going to do a special plot in a minute, but I'm just showing you a plot that's in the model. So I've got the actuals, which are the dots. Then I have the lines, which is what my model predicted. And you can see, even in the past, I'm not getting the exact values. And that's because I don't want it to train the actual values in the past. I'm just using the past um, as a signal to learn by. Okay, yeah, and what is the gray area? I was just going to say that. The gray area is, okay, how confident am I in those predictions? Is plus or minus, those values. It's the confidence interval. So in the future, you can see I've got this confidence interval, and that's just what this shows. So this is and see, starting in 2021, I'm not I have no actuals because I'm not including what I actually know about the future yet. Confidence bands, yes, thank you. Confidence interval, confidence bands, yes, both things. Okay, so this is one plot. It's kind of a base plot that comes out of it. Now we're going to create our own, very specific plot. Um, and so what I'm going to do, I created a function. Since we're going to run this plot over and over again, we're now going to show this plot every single time I do another prediction. Um, so I created a function to plot, and I'm going to plot my, actuals versus my forecast. So just to explain this a little bit, as you can see, I've got two different lines showing, my actuals is the red and my predicted is, the blue. And you can see now I'm going into the future with my actuals because I actually know the future and I want to compare my predicted with that actuals. And you can see in the future, I'm actually picking up generally that pattern. Based on the past, it's pretty close. Um, so let's look at how we're doing this. So I'm creating two different plots here. First, I say, okay, I need a plot, and now I'm gonna add an axis 0, 0, 1, 1. I forget what that does. That does for me, but I'm plotting DS versus Y. So my date going across the bottom, and then my Y going up, my consumption going up, and A1 is my actuals, and I'm saying R minus. So that means use a line plot versus and make it red. So that's what that plot is. So my actuals. Then I'm saying, okay, on the same axes, so I do this twin X, I plot my forecast. And my forecast is, I take the Y hat out of my forecast and plot it versus the date. And I call that predicted. And then, both of these have different axes, different mins and maxes. So I sync up my y-axis for my predicted versus my actual using this, set the limits, for these y-axis, and then print a label. So this is what it comes out to be. And I don't really care a whole lot about the past in terms of, actuals versus prediction. So I'm going to zoom in on my future. So I'm going to cut my data frame, my actuals data frame down to be just everything that was, in that virtual future. So everything after 2021. So I'm doing a filter on my data frame for my date greater than 2000, 2021 and beyond. Same thing for my forecast. And I plot that. Now I've got a zoomed in version just for my future of, prediction versus actual. So I can now say that, yeah, it's pretty accurate. It's picking up the seasonality, it's picking up the trend. It looks pretty good. Um, so that's generally our predictions. Something else that uh, Facebook profit gives you. Um, let's see. So question is why blue at the end is down and red high? Probably if we go look at, so red is what the actual, so it's actually going up, but the predicted said that it won't go up. If we go look at earlier years, probably almost every other year, it doesn't go up the same way. It goes down. So, our prediction is going to try to pick that up, pick up what happened in the past. It just happens that 2003, the um, the trend changed. The seasonality changed. That's why it didn't do so well. In the previous year, um, it's kind of the same. It predicted that it would go up and then down for January, but it actually went up. So yeah, you got to keep that in mind that it's not going to be perfect because you can't really predict the future. So, right. Yeah, uh yeah, maybe for some reason there's better energy efficiency. Maybe it wasn't as cold of a winter, you know, that you don't need as much or maybe it was a colder winter, so you need it more because the actual actually went up. So that's why you would have, inaccuracies. Something that the model gives you is let's look at the components. So I said that there's a trend, that there's a seasonality, um, that there's holidays or whatever. We didn't specify any holidays or exceptions, so we did not get any of that. But we do have these other components. So we said we ran this part of a model, this actual plot components, and this is what the trend does over time. It goes down fast to start with and then goes down slowly. So it's a little different. And then uh, we can at the very end, going into the future, we're seeing the confidence band, start to expand as we go further into the future. So that's the trend, which is the long-term, direction that it goes. And then we have seasonality, which is within the year, what does this thing generally do? And this is, January, February. So it's a little bit too, it doesn't really go up and down that much, but we do see that we have a peak just after July going into August. Um, So basically, it's like it's plotting these points and then adding the curve to make it look like a full line. So that's like the average seasonality. Once you take out this trend, if I subtract out the trend, then every month on average is going to look like this. And then for some reason it prints them twice. I'm not sure why it did that. Okay. So, yeah, those are how we're supposed to explain those gaps. Well, we're just kind of working around it. Facebook profit, it it worked around it. It said I don't need those gaps in order to do the predictions, so it just it went around it. And we'll see how we can actually go in and specify that in a bit. Okay. So that's some visualizations, but we need to actually come up with some metrics to measure our forecast on. So our metrics that we're going to look at are mean squared error and R2 error, R squared error, which if anybody that's in statistics, understands what R2 error or these mean squared error, R squared error, mean average error, mean average percentage error. So these are different measurements of error. Mean squared error, it just means that. Take the difference between actual and predicted, square it so that it's always positive and that bigger differences count more. Add them all up, and then let's take the square root. So this is actually the RMSE. Let me put the R there because we're taking the square root of it. The root means squared error. So we add it all up and then take the square root. And the difference between the actual and the forecast. That's what we're calculating. Um, so that's one, and I'm creating functions to do this because we're going to do this many times. Okay, so adding penalties for L1, L2 to the errors. Okay, this is not a linear regression, which is what you use L1 and L2 for to keep the parameters that it's calculating low. Um, you don't do this, we're not doing a linear regression, so you don't really do, those types of uh, things. Um, and yeah, you don't really add those to the errors. You add those to the parameters that it's calculating. But yeah, that's all different type of, not where we're using Facebook profit. That's where we're using and doing a uh, uh, different type of prediction, different type of estimation. But so we're calculating the RMSE, the R squared error, which means how much of this is random. And the closer to one that R squared gets, the more accurate it is. Mean average error is, instead of doing the squared, or mean absolute error, we just take the absolute of each one of the errors, add them up, and take the average. So I'm basically creating a function here to print all of these. And we've got a percentage error, which there is no uh, MAPE, actual mean absolute error by default. I created my own mean absolute percentage error. So that will calculate as well. We just take the difference, difference of the absolute, or absolute of the difference divided by the true. So it's how much of the true uh, is the prediction off, and then multiply by 100, so we have a percentage. So let's define those, um, and then I'm going to print what is the average error. Um, and the average error, or those different metrics, the root mean squared error is 1,653. So is this good or not? If we look at, where are our actual numbers, our raw numbers? Our raw numbers are in the tens of thousands. So if we're off, 1,000, 2,000, or whatever, then that means we're not that close, but we're not that far. We can tell, we can see the trend, we can see how close we are, and then what percentage off are we? That's kind of a more better, uh, what are all of these errors, on average? It turns out it's around 1,000, 1,600 on average. R squared, how much of the variability is explained? About 90% of it. So 90% is pretty good. Um, yeah, when you're anything over 50%, means you're winning. You're doing better than random. It's when it's like zero point 0.3, then you're just like off. Your model really isn't tracking very well. Mean absolute error is around 1324. So it's in the same range as the RMSE. And this says we're about 5% off. So plus or minus 5% is what we are, or plus or minus 2.5% is what we're off. So it's not bad. Um, all right. So any questions up to now? Because now we're just going to start tuning our model. This is the overall basic Facebook profit process. From here on, we're going to start tuning the model, looking at it from a little bit different perspective. We're going to repeat, a lot of what we did, but for hopefully making our model more accurate because that's the goal is to come up with the most accurate that we can. And yes, the you're on the same track as I was. Let's take a break. We're just gonna do 5 minutes. So a total of 10 minutes altogether. Um, so yeah, let's start a 5 minute break and then we'll go for another half an hour looking at all the different uh, tuning of this model. And then we'll actually talk about the program more toward the end, and then we'll leave some time for questions, and then that probably will take us right to the end. So yeah, let's go ahead and take a break.
Yeah, so now that let's all be back by 9. And in the meantime, I just wanted to address like two questions that I came across. So there have been people asking if this is a recorded session. This is not, this is a live webinar. We have been trying to answer as many questions as possible. And as you all know, we have limited time and we are trying to address most of your questions in the chat. If your questions have been missed, please share them in the Q&A and we will try to take those questions up in the Q&A section as well. So yeah, with that, please go ahead and for your break and try to be back in time. I hope all of you are back from your break. Please let us know in the chat. We'll wait for another minute. I can't see a lot of responses. So, all right. Chris will join in now. So, before that, I just wanted to quickly address two more questions. I think I've answered a lot of questions in the Q&A as well regarding the certificates and the recording. And a few of you have also joined a little later, and I saw your messages as well. So for all of you, I just want to quickly say it again that you will have to fill a poll that will be launched towards the end of the webinar to receive your certificate and the recording, and that will be shared with you towards the end of the webinar. All right. So with that, I think Chris, you can continue.
All right. All right, let me check the questions. SL and CL value of the model. How much percentage micro average? I'm not sure what SL and CL value of the model are. Maybe you can explain. Okay. Um, share the collab notebook link at the end. I mean, it hasn't really changed. I'm just running everything. Um, okay, let's see here. Are the shadows showing over under fitting of the model? No, the shadows are a confidence interval. So it's just like plus or minus a certain amount that tells you, how much can I count on this result? That's what that means. And the more you go into the future, the bigger the confidence interval is because it's just you know less about the future as you go into the future. And we'll see that in a minute. Once we've done some more some of this tuning, then we'll just do some predictions and see what the confidence interval looks like as you go into the future. Basically the standard deviation of each point so that as long as you're staying within a range, you're good. Yes, that's a good way of explaining it. Okay. All right, so we did a um, linear trend. You can see this is a line, going down. But there's also, maybe let's try the logistic, a curved approximation. And with that, we need to add this cap column in order, to use it to do the logistic. It's an addition. We can dig into what that exactly means, but it's just something you have to have. And so what it does, same type of plot that we did before, but the logistic gives you, just a dot plot and just something in the future. That's all we're looking at now is looking at into the future, the DF test. Um, so this is what it looks like. So let's do the same kind of plot we did before we were creating it. And it's only the future. Now we're just going to focus on that part. Um, and we need to, where is it? And then what's the error? Something, let's see, let's do something real quick. Let's since we're only focusing on that part, we need to restrict our data to just that part. So we're not looking at the past. So I'm going to copy that and filter out the data that's um, before 2021. So DF actual and DF prediction. Doing a little bit of coding on the fly. So it looks like this. So it looks similar to what we had before. Um, maybe it looks a little better. Now it's actually predicting that we're going to go up versus going down like we did before. So and now we're going to actually look at the error of that. Um, okay, so the error, let's do the error of these two values. That's what we did before, right? Um, Sort of. We took forecast and restricted it to just that. So let's do both of these. Print error. Um, okay, it's the same thing either way. Okay, so we did restrict it to just that time frame already. So we can see now our error is actually off more than it was. 1791, our RMSE, whereas before RMSE was 1653. So doing this particular tweaking of equals logistic, gave us a little bit worse error and like a 5.3% uh, mean average percentage error. So it doesn't really help to do that part of the tweaking. The performance of the matrix has actually reduced, with logistic growth. So let's try some other things. Let's add seasonality. We'll add that part of the model back in and see what we get from that. And does this give us right? So it's all looks good. So now we have this monthly term added, a yearly term added. So it's added some stuff, not just trend. So seasonality gives us a bit more information there. So let's plot them together. And again, I really should restrict it to just that future time frame. So let's do it this way. So yeah, let's. Okay, now it even looks further off. So adding the seasonality didn't really do us much. Um, let's see. Yes. Plotting that. All right. So let's see what the error comes out to be. Now it's up to 12%. So really, either we didn't do the seasonality right. Okay, yes, I will share this revised notebook. I'll put this one up on GitHub when I'm done because I am making some minor tweaks to it. Um, All right, so seasonality really didn't do us that well. All right, so now we're gonna do, let's see, add change points. All right, so I'm not sure what that is. Oh, I'm not gonna worry about that part. All right, so now we're gonna, there's some dates that we're missing. So I want to add, I want to say, or dates that are different. So missing data, we have missing data, and we have like the lockdown during the lockdown. So I'm adding some data, so some points to it so that we can, that holiday or exceptions, we're adding that into our model. Um, so we create a table like this where here's a holiday name and then a date that goes from a particular day to a particular day, and then the number of days in that date range. So we have some missing data and we have some lockdown. So these are the special days, and we want to uh, ignore, treat those date frames differently. So the way we do that is by saying, in our model, profit holidays equals lockdowns. And here I'm setting M2 to our model rather than model, but it doesn't really matter. So I'm going to train M2, the profit model, and do the same thing, predict just like before, and then plot the forecast just like we were doing before, just to see a baseline. And here I've got uh, so let's just look at just the future time frame. So this should be more accurate because we've now accounted for those weird time frames. So maybe it's more accurate. Let's see what the error is now. Our error is 5.5%. So it's still not it's still worse than just treating it all natural without making any changes, any tweaks to our model. So the model by itself was just fine. Okay. So any questions up to now? I mean, this is typical. When you tweak around the model, you're gonna find that sometimes you're thinking you're going in the right direction, and what ends up happening is you actually get worse. So you just take a step back and then move forward. So, but we are going to go ahead and keep our holiday data set and actually at this point do actual future predictions. And I'm going to predict for several time frames, for 1 month in the future, for 6 months in the future, and for 9 months into the future, which we'll do years in the future in a minute, but we'll start with just months at a time. So I'm going to start from scratch. I'm going to create, another model and fit to the whole data set this time. Yeah, I'm not going to go back 2 years and pretend like I don't have that additional information, that those 2 years of data. Um, I'm no, I'm going to predict just going into the future. Um, okay, so no, I'm changing. I'm not gonna use the test anymore. I'm not gonna use that time frame anymore. That time frame for the DF test is 2022 and 2023. I'm actually just gonna go into the future. And it starts right after, the data frame for DFM1, the last date that's in DFM1. and I'm only going to go for 1 month. And then do my predictions. So I'm creating a base data frame with just one date, 1 month into the future, and then predict for that 1 month. And let's see what it looks like. Looks like this, and I just have 1 month out here that is not accounted for with my actuals. So now you can see I'm using all of my data, not just the training data, but training on all of my data. This is very typical um, for predictions. Is you figure out, okay, what's the best way to train, and then when I'm all done, I use that method, but I don't train on the training data. I train on all the data and just start predicting into the future. So that was for one period. Now I'm going to do exactly the same thing, but predict on 6 periods. So now you can see I've got more going into the future, not just one period, but 6 periods. And I'm going to do it again now with 9 periods going into the future. So now I've got like 9 months of future data. So this still really isn't that much. I want to see what it looks like going way into the future. So now I'm going to switch from not from doing by month, I'm going to do by year. All right, so I'm creating another set of my data. Let's see, okay. This is it's like the same data, but okay, this is a very different treatment of my data. Now I'm only using 1 month of data. I'm doing a kind of a different type of prediction. Instead of each month of the year, I'm now just going to predict January going into the future. And here I should be just looking at what is that overall trend, because I'm taking out the seasonality altogether. So based on this one, I'm going to predict just 1 year into the future, then 10 years, and then 20 years, and see what it looks like. So if I predict just 1 year into the future, I'm showing a big drop. I don't know why it's thinking that, because every year before that really wasn't dropping that much. But then all of a sudden, we're predicting a big drop. Um, it just doesn't seem to be very accurate doing this kind of prediction. Uh, for 9 years into the future, okay, I'm showing a drop and then increase, drop, two drops, increase, two drops. So every 2 years dropping. I kind of see that. 2 years, increase, 2 years, increase. So it's kind of picking that up. Um, so now let's do 20 years in the future. We can see that it shows that dropping still happening, which really doesn't match the trend that came out when we had the month in it. It was showing a leveling off, but this is what happens if we predict, just with a year. Uh, that was 10 years. Now we're doing 20 years, and it's 20 years is taking a minute to run. So we're now relying on, Google Colab, its processing, and sometimes it just isn't that fast. We could beef it up, of course, but then we're starting to spend some money. Okay, so this is what the trend shows, going further and further and further in the future. All right, so now let's take it and look at it year by year, but as well break it down by month. So we'll go back to our earlier data frame where it's by month using the holidays, and then we're going to go 12 months into the future and see what it looks like. So yeah, we've got some decent stuff. It seems like our confidence interval is expanding a little bit, becoming less. Now let's do 10 years, 10 times 12 months, see what that looks like. So 10 different years, and you can see we're getting harder and harder to predict. It's showing our confidence band is growing. So this is if we're going to use this model to actually predict, into the future. It's got the seasonality pretty good, um, and the trend as well. It seems to be dropping just a little bit going forward. And then finally, let's just do 20 months or 20 years going forward. We can see we're almost, we're really not able to predict very well way out in the future. Our confidence band just go down. Okay, so a comment here, very interesting model, especially for countries which have launched new development visions like Tanzania, development vision. Yep, yep. This is the kind of things that governments, governments have lots of data at their disposal, so they can do stuff like this. This is how they know what's going to be happening in the future, how they, can guess based upon the past. Um, okay, so let's look at this same data frame, but instead of or the original data. But instead of, as a total uh, you know, by month, let's break it down by borough, so that we can predict each borough separately. So here's, a data set of the average consumption, not just by month, but by month and then borough. Uh, okay. So now let's predict based on that. And plot each one of those predictions. So it's creating them first. And how much are we taking into the future? Let's see here. Taking 3 years into the future, what does it look like, by month? So like for the Bronx, if we're predicting, looks like this. Same seasonality, same levels that it's staying at. Brooklyn as well. Oops. And Manhattan. So it's just, you know, taking it and extending it to look at the data a little more in depth. As I'm sure you can tell, there's a lot more that can be done with this stuff. And also we limited it down to just, the five boroughs rather than including, there were some other miscellaneous ones. Um, okay, we are using which training method to train the model or model evaluation through accuracy, precision, recall as prediction. Please once confirm the more clarification. Okay, so under the covers, what does Facebook Profit do? Um, you just have to look that up. Um, I didn't really dig into what does Facebook Profit, how does it do its predictions? How does it do its calculations? Um, I just included a bunch of information about it, but I would just say Google it and dig into why is it, how does it do it? Um, it's interesting, not ideal for high frequency trading data. That's if we wanted to use this to predict the stock market. That's a big application of this type of prediction. All right. So yeah, that's pretty much it. For this, I'll put it up on GitHub. This once I've run it, I'll go ahead and just save it and download it, get it up to GitHub. So you have it, and you can apply it to other data sets. Whatever you can find. Whether it's try it on stock market data, see how well it predicts. Just like one day ahead, something like that. So yeah, that's pretty much it. So just questions, and I know we have some more explanations, some description of the course that we'll dig into this much more in depth. In the course, time series modeling is it's a whole course in itself. I condensed it down to just a couple of hours. But yeah, this is something that you'll learn much more on, the theory behind it. I have not tried for stocks, for Facebook profit. Yahoo Finance is where you would get the data. So yeah, definitely should do that. Um, I'm gonna try it myself and see what happens. I just never really took the time to do that, but definitely should. It's a lot of data, but we'll see how it goes.
All right. So I think I'll start sharing my screen, Chris.
Okay, yep.
All right. I hope my screen is visible to everyone. So, Chris, we covered a lot of information in today's webinar. So, could you quickly recap what we covered? Because I saw at least 4 to 5 people join later. So, they just wanted to understand what we did. So, an overview of what was covered.
Okay, sure. So to start with, getting the environment up and running. Thank you guys for your tenacity on that, for your patience, for getting everybody else up. I love seeing people doing this for the first time. Uh, getting the environment up and actually starting to run some stuff yourself. Google Colab is great for that. Um, so so yeah, started with that. Then getting the data loaded. Um, and loading the data, there's a lot more things we could have done to the data, but what I you know the I did just a couple of things because I mean it's a whole class on cleaning the data. There's so many different techniques. So what we did was just cut it down to a couple of the columns, look at some averages. There was a part in there where got rid of missing data. Um, Duplicate rows, that's another thing. So sometimes you have that. So there's a easy way to do that. Converting dates, we did that real quick. Converted the date from a text to date format. Uh, yeah, inconsistent category names. Right now, everything was kind of well formatted, in this data set. But let's say Bronx was sometimes upper, sometimes lower. Well, that would have messed everything up. So we would have needed to, do some conversion on that. Outliers, we went ahead and left the outliers in there. That's outliers and also missing data. We just kind of left it as is, saw what Facebook could do. But that's another thing that we would definitely want to do is take those out and see how the model would do, otherwise. And wrong data types. So we did some data type conversion, to the the date, but everything was pretty good there. Yeah, we did lots of visualizations, line charts, lots of that. There were some base visualizations that were in the Facebook model. We kept on showing those Facebook profit model. Yeah, time series, that's what this was all about. So we showed a lot of time series where across the bottom you had the time series. We had a category, type of histogram. Uh, didn't do a rolling average overlay. That would have been something nice to add. See how if we took a like 3 months rolling average, see how you do that a lot of that in stock uh, predictions. Compare what's going on to, okay, what has been going on. That's what to do when you get that rolling average. Histogram, we really didn't do a lot of histogram, but we did, plot them and kind of see how things showed up that way. Heat map, we didn't do that, but that's a very popular thing to do. Correlations, look at how the data is correlated with itself. Yeah, and make your graphs so that a user could come along and do, some of their stuff, like look at the Bronx versus Queens, way to interactively make the changes to the filters. That's a great thing to do on graphs, on charts. And within Facebook profit, we did the forecasting. It might have had some AI in there rather than, I mean, that's really what AI is, right? It's just, predicting, is interpolating, is, guessing, educated guessing. So, that's all these new generative AI models are doing, is guessing what the next word phrase would be based upon a set of bunch of words and phrases, the context. So that's a version of forecasting, of predicting. So yes, Gen AI, that's very good at forecasting. Um, so yeah, so I showed you many times, we fit the model, and then once you fit the model to the training data, then you do a generation of the future. That's generating the forecast, which includes those confidence bands, and you could go as far out in the future as you want. Just your accuracy will just go down as you go out. And yeah, your dashboards, your graphs, they can have many different lines on them. You combine them all together, so that becomes a dashboard. More than just one line, one set of uh, points. The automatic updates, we just would need to run it again. So, that's we recalculated the forecast many times, but that could be in a loop, could be an interactive loop, where you try different things and then have it automatically run. So we could have done that. That's just that'll be more of like automating, this process. What we did was just more of a demonstration.
Yeah. Thank you for explaining all of that, Chris, and it was a wonderful workshop. We see a lot of comments as well from the audience. So thank you for also giving them a recap of what we did today. And to all of you out here, uh, you just worked on this along with Chris. So now you can imagine doing this at work every day. So we have a Microsoft data science course that is going to give you a structured path to build these as well. And right now, we know that data science is a booming career. There are lots of opportunities out there. Even with AI coming into place, it is still one of the top trending careers right now. So, Chris, one last question about why this is the right time for someone to move into data science, and what are the trends and scope of this field in the coming years?
So I'm mute there. Yeah, so data science, last decade is when this really took off. Um, people we ended up people realized how much data we actually were storing, and we devised ways of using it that were not your typical just transaction processes, where you're using one record of data at a time. We figured out ways of using it, in a statistical method, a whole bunch of data at one time, calculating it. So then data science really grew out of that. The predictions, the way humans really look at things. We don't do things like one thing at a time. We do things in a parallel fashion. We sum up the whole environment and make a decision. So that's, once we had enough data and enough processing, then we were able to do that. And then whoever learned those methods, you know, went into a new direction. Went into the data science, AI. Um, I think that 36% job growth by 2033 is way understated. If you take, what's happened as of now, the way data science has grown, it's grown from nothing to what it is now in just the past, 10 to 15 years. It's, now with the Gen AI explosion, it's just going to keep going, and, 100% growth, every 5 years, I would say. So, it's not, you're not too late, definitely. Just keep it going. Um, and yes, that average annual salary, that really depends on where you are in the country. I'd say that number is pretty accurate. For data scientists, for data analysts, it's probably around 100K, I would say. Um, but if you go West Coast, add 50%, easily. Um, that's kind of the thought process. East Coast is traditionally a little bit lower, or go in the Midwest. Just companies are realizing, how important their data is and how much information they could get from it. And there's so many different aspects of data science you could get into: data governance, data analytics. Yeah, I mean, there's just so many different ways AI can be used. Get into agentic AI, where generating all this code is, you could do it all, just by talking to ChatGPT or Claude or any of those. Um, but yeah, it's growing, and as long as you have an analytical mind, then definitely, you're qualified. Yeah, any engineer, marketing is a great application of this. If you think in a marketing manner, you're already, on the way. So definitely get into there, and it doesn't take that long. You don't need to go for a 4-year degree on this. A boot camp, is ideal, because now you're learning, from industry, people that are out there in industry, people that are sharing, their experience, where they've actually done the work. Academia, by the time you're learning in academia, it's already a few years old. So, and it's just, things keep on changing so quickly. Definitely a boot camp that, good quality boot camp that stays on top of things. And I know that's the way Simplilearn's always been. They've kept up with the times. So yeah, it's exciting. I'm excited for all of you guys.
Thank you for sharing your perspective on this, Chris. It's been great hearing from you, and also the scope of this field as well. It's wonderful to hear your insights on this. So for everybody else, I'll quickly introduce the data science course that we are offering at Simplilearn. This is in collaboration with Microsoft. I request all of you to give me 10 minutes of your time at max. I understand that this is a very long session, and or you might be tired, so I will try to wrap this up really fast, but this could be really helpful for you guys as well. So just bear with me for some more time. So I'm going to start with the key highlights of this program, what's actually in this if you decide to join. So we focus on AI and we have an AI driven curriculum. So we cover Python, SQL, ML, and more. So you are going to learn through a structured AI driven path and deep neural networks as well. This is a part of the curriculum. So I'm not going to get into depth into all of these aspects today. The curriculum is based on how data scientists actually work today. And this is going to be real world implementation as well. Second, this is an industry recognized master's certificate. So you're not going to just finish a course, you're going to get a data science master's certificate from Simplilearn in collaboration with Microsoft, like I mentioned earlier. And this is a 11-month course. Apart from that, the third point is on how you can master generative AI, LLMs, RAG, MLOps, Fabric, ML, and a lot more. So this is the part that most programs actually skip. So you will go deep on generative AI, RAG pipelines, MLOps, workflows, Azure ML, Power BI integration, and a lot more as well as a part of this course. Another highlight that we would like to mention here is the lifetime access for continuous learning. So we all know that this field is changing fast with AI. So with lifetime self-paced access, you can revisit any of the modules and keep updating yourself even after a few years. Apart from that, we focus on hands-on tools with hands-on experience with tools that actually matter. So you are going to build real proficiency with actual data scientists use. So leading ML frameworks and implementing this every day. And finally, we have this is crafted to launch you as a data scientist. So this is not just a random collection of topics that you have in every module. So every module, you will be learning something new and you will be applying this through multiple labs, through the labs that we offer as a part of Simplilearn. And one other highlight we would like to emphasize here is live guidance from industry experts. You sat through this webinar and you know how the experience has been. So we have mentors like Chris take all of our sessions. So you will be in very good hands. And finally, the capstone projects that we offer. So we have capstones from 3 domains and we will be covering 15 plus projects as a part of this course. So you will walk out in 11 months with a portfolio of 15 plus real projects across 3 domains. So when you sit in an interview and they ask you to show something that you built, you already have worked on all of these projects. So these are some of the key highlights. And with that, I would also like to move on to the course curriculum. Again, in the interest of time, I'm not going to go dive into all of the modules. Here is a QR code that you can all scan to understand each module better. I'll just quickly walk you through what modules that we majorly cover. So we start with Python refresher with AI. And then we move on to SQL certification course. Then we cover advanced statistics followed by applied data science with Python. Then we have machine learning using Python. We also cover deep neural networks, TensorFlow, Keras, PyTorch. And then we move on to data science capstone project. And we also have electives as a part of this course curriculum. Again, these are just the module names. Each module has different segments under it. So please go ahead and check it. I saw a lot of questions about Python. If this is suitable for someone who's new to this course, you can definitely go to this course page and see if this is something that you are looking forward to having. And then moving on to the industry projects. So I'm not going to walk you through all the 10 today because I want you to notice something here on the screen. You can see that every one of these is a real industry problem, and you will be practicing and resolving all of these so you can imagine the impact it can have. Even if you're working at any company, you will be able to solve their problem. So I'm just gonna highlight a few I feel are important here. I think the number one that a project that we do is sales analysis. So this is something that everyone in business cares about, and that is sales data. In this project, you're going to work with real clothing company data across Australian states and use Python to help that business make smarter decisions going into the next quarter. So think about your own company right now. Someone is probably currently doing this in Excel manually, taking hours, but you will be doing it in minutes, and you will be producing insights that they care about. And you could do this for your own company, for your business, or you could implement it after learning this concept as well. And then there's employee performance analysis. I'm not going to explain this in detail. You can find this in the course page as well. And like Chris mentioned, we also have marketing strategies with exploratory data analysis. So this is something that has been booming. Everything is about data right now, and marketing without data is just like guessing with a budget, right? So here you're going to do a full exploratory data analysis and hypothesis testing to help marketing team understand what's actually driving acquisition and then build a better strategy. So every marketing team thinks that they know their customer, and you're going to do that real time and help marketing teams. This could be a game changer for you if you are in the marketing field as well. And then you move on to build an online car rental platform. So this one's about object-oriented programming. You will build a platform that handles vehicle listings, bookings, and customer interactions. So this is also a very common question in interviews as well. So this could be probably helpful for somebody who's trying to get into this field. And then you have science QTech employee performance mapping. Again, this is related to HR. Not going to go into this in depth. And then we will cover data manipulation and reporting with Powered BI. This is also something that you come across during interviews, could be really helpful for you if you are someone interested in this. And finally, we've only mentioned 7 projects here. There are a few more. You can refer to that in the course page, like I mentioned earlier. So the final project is virtual project management consultant. And for this final project, you will use ChatGPT as a virtual consultant to structure prompts for project planning, risk management, and also team performance. So this is generative AI applied to real business problems. And this is exactly what people are looking for right now. If you are reading the news, if you know the trends, you know where AI is headed, where the future is headed. So these are some of the projects that you will be working on if you are interested in this course. Right. And as a part of this course, we will be covering 13 plus tools and 17 plus skills. I'm again not going to explain all of this in detail. The course, I hope all of you got a chance to scan the QR code. If not, we will share the deck with you and you can go to the course page, or even right now, you can just search for data science course and you will be able to get all of the details. And with that, I think I have covered all the key highlights of the course. This is a major decision which I understand, but probably for someone who's interested, this could be beneficial. And the course investment for this course is for Indian learners, it's 50,000 rupees. And for US learners, it's $1,449. And what is included as a part of this, you will be receiving an industry recognized certificate in data science with AI. You will also receive Microsoft certificates upon completion. And like I mentioned earlier, these are live online interactive sessions led by top industry experts. And finally, you're going to get hands-on experience with latest tools and work on real-world projects. One thing here is that we believe in real-world projects and working hands-on on everything that you learn. So that's our focus here. If you are someone who is interested, I will quickly launch a poll, and you can click on a yes, and our team will reach out to you at the earliest to answer all of your queries. Even if you're confused and you have questions, they will be able to help you with that. And I understand that I'm not going to tell you that this is a small decision. It is not. But I definitely have to ask you, a year from now, are you going to wish you started today, or are you going to be exactly where you are right now, like thinking about it? Sometimes the only difference is that you make that decision or you take that call, right? So think about it. If you are someone who's interested, please go ahead and share your responses with us. We will be more than happy to see all of you join us and be a part of Simplilearn family. As you all are sharing your responses, I will also take a look at the Q&A box. I did say that we will try to answer all of the queries. I'm sure Chris has answered a lot of your questions from the chat. So we will wrap this poll up in another minute or so. So please share all of your responses. And in the meantime, I will pass on a few more questions to Chris. So, Chris, there are a lot of questions in the Q&A box. So I'll ask you a few questions. So this person has actually asked a few questions, and he's also asked, how can I do Python from basic level for beginner AI field, and what chapters comes under Python intermediate and advanced level, and what chapters can I do from basics? Because he's a beginner and wants to go into AI field. Chris, are you able to hear me?
Yeah, could you repeat that question? I didn't see it.
Yeah. So basically, this person wanted to know the chapters or modules he has to cover as a beginner to in Python, basically.
So where to learn um, the Python to start with?
Yeah,
Um, I mean the beginner Python that's good. It's in the course. Is a good start. But yeah, I mean there is other stuff. Trying to remember some of the name of the like the schools. Like I think it's WWW school is really good for starting off in Python. Hold on a second. For Python, is that it? W3 w3schools.com. This is a good, very, very, very beginner uh, starting to learn Python. Um, the practice um, hacker rank is a great way to practice Python. I'll put that. Once you kind of get going, but something like Udemy or Coursera, those are good resources for actual courses, in beginning Python. But there will be a small cost, to those, whereas like that W3 schools, that's a good one, that's free.
right. I think I can pass on one more question to you. And before that, there's one query, and it's about if the chat is monitored, please respond to my request to post a link to the recording. So yes, you will be receiving a recording. So I'll quickly stop this poll and launch another poll for you. For the certificate, if you share your details in the poll, you will be receiving the certificate, the recording, and the slide deck as well. And we have not been able to answer all of the questions in the Q&A because we've received a lot of queries and we had limited time to answer all of them. We tried to cover as many as we could, but we were not able to take up all of your questions. We understand that. Is there Chris, there's one more question. How is agentic AI reshaping data science?
Oh my gosh. Agentic AI, it's not, well, okay, we're talking about using agentic AI, or are we talking about creating it? Because let's start with using it. So when you go to ChatGPT or any of these platforms, you're now using agentic AI. They seamlessly use tools. Okay, that's what makes agentic AI different than just ChatGPT, the LLMs. Um, that they use this tool to reach out to the web or reach out to different platforms to pull data back. Um, so So that's really how it's changing using it. In terms of data science, in creating agentic AI, it's just a whole new thing that is added on top of LLM. So when you go to ChatGPT or you use an LLM model, you're just asking it a question, and getting back an answer. Um, it uses the question as a context to generate an answer. So what agentic AI is it says, okay, I can have that LLM actually go and do something, perform some kind of action, go out to a web page and look for current airport airline prices, actually book an airline, book a hotel. Those are the tools, those are the actions that just the ChatGPT can't go and do. Just using an LLM to answer a question. But agentic AI will actually go and do something. So that's really the biggest, difference that what it's how it's changing things. Whole
So
new thing,
thank
whole
you
new
for
world.
thanks for answering that question. And I see a lot of people sharing their details in the Q&A. So I'm going to end this poll right here, and I'm going to quickly launch the certificate poll. I hope the poll is visible to everyone right now. Once you fill up this poll with your full name, you will be receiving the recording, the slide deck, and the certificate within 48 working hours. And if you don't receive it within 48 working hours, then you can write to us at webinars@simplilearn.net. And if this poll is currently not visible to anyone, then you can again write to us at webinars@simplilearn.net. Just tell us your name and that you've stayed till the end of the webinar, and we will be sharing the recording and all the assets to you as well. And I saw a lot of queries about the data set and all the assets that were shared during the webinar. So we will also share all of these details with you post the webinar, so you can take a look at it and work on it at your own time and pace. So I hope, yeah, even the collab link, we will share all of this with you guys. I hope that answers a lot of queries that we've received in the chat and in the Q&A box. And as you all are filling up the form, I think I would also like to take this time to thank Chris for being such a wonderful speaker during the webinar. It was a wonderful session, great insights. We've learned a lot, and we covered a lot as well as a part of this 3-hour workshop. It was a long session, but thanks for addressing almost all the questions in the chat. Again, we were not able to address all of it because of the huge volume of queries that we had, but we'll try to do that in our next session. So, Chris, once again, thank you for being a wonderful speaker. It was really engaging and extremely insightful. So, thank you. And what is one piece of advice that you would like to leave our audience with? Because a lot of them have stayed till the end of the webinar.
Uh, One piece of advice. I guess a big one is your portfolio. Whenever all these projects that we talked about, these projects that you'll do during the class you want to make sure that those are available for potential employers to see. So you need to have GitHub set up for yourself. Get a link on your LinkedIn. Make sure that you're pointing to your GitHub and get all these projects out there. Get them formatted really nice, organized, in a decent way. And then, even go one step further and create a portfolio website. And these days with like Replit or Lovable, there's several of these, coding, vibe coding, platforms. Just it's so easy to just tell it what to do and it just does it. So get your projects out there, get them ready to show, because that's what employees are going to be looking at. They want to see, what kind of stuff you've created, how organized you are, what's your style like. That's great for just sharing with your friends and stuff, and coworkers, that as well. So that's a big thing that I would say.
Yes. Thank you so much. That was really good advice, and I hope all of you follow the same. And with that, we are coming to the end of the webinar. I can still see a lot of you saying that you can't see the poll. So right now you can see this mail ID webinars at simplylearn.net. You can write to us, tell us your name, and tell us that you stayed till the end of the webinar. We'll share all the resources with all of you. And with that, I'm going to quickly end this poll right here. And I would also like to thank all of you for staying till the end of this webinar, for being such wonderful audience, for sharing your questions, and for staying throughout this 3-hour workshop. And you guys were really engaging. Wonderful to see you all. And I really hope to see all of you in our upcoming webinars as well. One more query I would like to answer is, you've asked that you've just shared your name. Yes, that's the only detail that we require. You will be receiving all of this in your email ID within 48 working hours. So with that, once again, thank you, everybody. I hope all of you have a wonderful evening or day ahead. And I really hope to see you all in the upcoming webinar.